Hi, and welcome to this next video on trigonometry. Okay, so in this video, we're going to be discussing how to use inverse trigonometric ratios in order to find measures of angles. So in the last video, we used the measure of an angle and set up the trig ratio in order to find missing sides. Well, we can also find missing angles if we have sides. Okay, so we learned about the sine, the cosine, and the tangent, and how to find them, and then also how to use them to find missing sides given the measure of an angle. Well, now, what if we're given the sides, but we want to know the measure of an angle? So let's look at the triangle that we have here, triangle ABC. And in this case, I want to find the measure of angle A. So I'm going to still use the same rules, okay, because what it tells me is that if angle A is acute and its sine, and the sine of A is equal to x, which would be our trigonometric ratio, then we could say that if I take the sine inverse of what the trig ratio is, which we're going to use as x in this case, then that will be equal to the measure of angle A, okay? And the same is true for the cosine. So if angle A is acute and the cosine of angle A is equal to x, then the inverse cosine of x is equal to angle A, or the measure of angle A. And then the same goes for the tangent. Okay, so basically we could, I'm going to quotation that just to show that it's the same. So basically if cosine of A, not cosine, we're in tangent here, sorry about that. So if tangent of A is equal to x, whatever that ratio is, then the tangent inverse of x is equal to the measure of A, okay? And the reason we don't just say A is because when we name an angle, we have to name it as the measure of that angle, okay, when we're talking about the measure of the angle. All right, so basically, what does that mean? Well, I can use angle A if I set it up, okay? If I'm looking at angle A, this is my opposite side, and this is the hypotenuse. Okay, so before we said that the sine of A was equal to the opposite side over the hypotenuse. Well, now, instead of, if we need to find the measure of angle A, the sine inverse of the opposite over the hypotenuse is equal to the measure of angle A. And so that's what you have right here. It's that same thing. So that can happen for the cosine as well. So remember that this is the adjacent side. Okay, so the adjacent side over the hypotenuse, if we take the cosine inverse of that, we'll get the measure of angle A. And another way that we can get the measure of angle B is to say that the tangent of, or the inverse tangent of the opposite over the adjacent, just like we found the tangent was opposite over adjacent, we can use the inverse of the tangent to find the measure of angle A. So there's three different methods we have to find the measure of angle A, and each of which one we use will depend on what we're given, okay? So now let's put that into practice and try to figure out, okay, what does all of this mean? It's a lot of different ratios, and yes, you need to memorize how to find them. So instead of just memorizing the formula, remember how they're derived. So here I have angle A, all right? And I want to find the measure of angle A. That's what it's asking me for. Well, if I look at angle A, what do I have? If I look across, I have the value of the opposite side, which is 18. And if I look at the hypotenuse, they give me that this is 27. So which ratio do you use the opposite side in the hypotenuse? Okay, take a pause and look back at your ratios. So if you guess sine, then you're correct. So I'm going to use the inverse sine in order to do this. So I know that the sine of A is equal to the opposite, in this case, which is BC, over AB, which is the hypotenuse. Correct? Okay, well then these values, the sine of A is equal to 18 over 27 if I plug the length of BC and the length of ABN. Okay, and this works for any angle. It doesn't just have to be angle A. It can also be angle B. Okay, but we would have different values, of course. So now, and since I want angle A and I have the ratio, what I'm going to do is I'm going to say, okay, well, the sine of, or the inverse sine of 18 over 27 will actually give me the measure of angle A. Okay, so I'm going to find that measure by using my calculator, and you're going to have to use a different function. So if you have the TI-89, then when you plug it in, you're going to use the green or the diamond key. So green and then sine inverse. You should get a sign with a -1 on your TI-89. On other calculators, it may be noted different. But now in the parentheses, you're going to say 18 divided by 27, or if you want to reduce that to 2/3, you can before you plug it in. And so this here will give you the measure of angle A. So you should get 41.81 is equal to the measure of angle A. Okay, so 48.81 degrees, make sure that your calculator is in degrees. If you got some weird number, it's probably because your calculator is set to radians, so you need to change the mode. So your calculator does have to be in degrees. So I'm going to pause the video and let you find the measure of angle B based on what you're given. So you have to figure out which ratio you should use to find angle B. All right, so go ahead and pause the video and do that. Okay, so you should have gotten that the cosine of B is equal to the adjacent side from angle B. So we're here, right? We can use these trig ratios or inverse ones for whichever angle, as long as it's an acute angle. Okay, so then you got 18 over 27, the adjacent side over the hypotenuse. And then when you plug this in as the inverse of the angle, then you were able to get the measure of angle B, which is 48.19. Okay, so I hope this helps. And I want you to continue practicing with numbers 2 and number 3, and you can bring your work to class. So this is a part of your homework. All right, so when we get to class, we'll talk about how to solve right triangles completely. So I hope these videos have helped, and remember that you can refer back to them at any time you wish to.